Welcome, viewers. Today we have a topic we want to treat, and we are going to be doing the determination of moment in an orthotropic plate deck. Okay, and we are going to make use of a 20-meter span simply supported bridge, and haven't applied our life load on the bridge. We have the life load according to the British standard BD3701. We'll have the HB load and the HA load being applied on this particular 20-meter span bridge deck. Right now, we want to calculate the maximum moment on the plate. Now, before we go into the determination of the moment on the beams, we first of all need to obtain the maximum moment on the plate. Now, for us to do that, in obtaining the maximum moment on the orthotropic plate, the load is being applied on the plate. We can see the dotted line indicating the position of our HB load. We can see that our HB load, the distance between each point from here down to here, we'll have 1 meter, 1 meter, 1 meter along the transverse direction. All right, so on this shaded part, we have a uniformly distributed load. I'm not going to show more details as regards to the distance between the HB load and the HA load. So we'll leave that for now. Now, from this point down here, we'll have here to be 3 meters, which shows the position of our HB load. All right. Now we are using the HB load for 6.0 meters, 1.8 meter between each axle, the first and second axle, and similarly the third and the fourth axle, 1.8 meter respectively. Okay. Now, in calculating the maximum moment of this plate, the first thing we must do is to convert the point load, which are concentrated loads, to convert them to line load. All right. Now, for us to convert these point loads to line load, we have to divide it by the width of the plate. All right, the equivalent width of the orthotropic plate. Now, the equivalent width that we have demonstrated in one of our videos, how to obtain the equivalent width of the plate. We've demonstrated that in our previous video. So we can obtain that equivalent width, which is equal to 2B. All right. So if the equivalent width is 2B, what it means is that the line load that is going to be acting per meter width of the deck is going to be 2B. So it becomes 1, 2, 3, 4. So we have 4 P's divided by the width of the equivalent width of the deck, which is 2B. So the load that is going to be acting on the deck is going to be 4P divided by 2B, and you can see that in the second diagram here. So equally, we are going to have that load acting on each of the axle, 1, 2, 3, and 4. So we have the 4 axles, their line load. All right. Now, having gotten the line load in this case, the next we are going to do is to solve it as a beam. All right, like a line beam, we are going to solve it. In this case, we are interested in obtaining the maximum moment on the deck. All right, we want to obtain the maximum moment on this bridge deck. Once you can obtain the maximum moment of the bridge deck, of course, you can apply that moment to your girders to obtain the moment on your girder. But today we just want to concentrate on obtaining the moment to the maximum moment on the plate, the orthotropic plate. All right, so due to HB load. Now you can see the configuration arrangement to obtain the maximum moment. Draw the line beam. So you can see the line beam. From the line beam, For us to obtain the maximum moment on the deck, remember when we are treating determination of maximum moment of series of concentrated moving load, we did that in one of our videos. You can check that video out. You can check the explanation box to check out for that video. Now we have this point, this support, let's call it support A, which is this point. The other point, we can call it support B. So when we place the load, to also obtain the maximum moment, we have to place the load such that we have it as this. To obtain the maximum moment, you can see from here, the distance between this point is 6 meters. So when you divide 6 meters into 2, you are going to have 3 meters on both sides, 3 meters on both sides. Now you divide the 3 meters into 2, you are going to have 1.5 meters, 1.5 meters. So you place that 1.5 meter at the center of your beam. So if you place 1.5 meter at the center of your beam, this is the arrangement you are going to have. Haven't gotten this arrangement, the next you are going to do is to take moment about point B so that we can obtain the reaction at support A. All right, so we'll do that. Having done that, the next step the next step we are going to take is to calculate the maximum moment. Of course, the maximum moment is going to occur under the second axle, okay? So let's work that out and find out what the value for the maximum moment is. All right, so in obtaining the maximum moment, let's call our sigma Fy to be 0. So total reactions becomes 4 times open bracket 4p over 2b. That becomes the total reaction. So if we take moment about point B equal to 0, we're going to have our Ra to become 1.7 bracket 4p over 2b. All right, so this becomes our Ra. So the maximum moment will occur under the second axle from our left hand side, like I said earlier on. So in doing that, you are going to say the maximum moment becomes the reaction at A times distance to the distance from A to where we have the second axle, and that is 8.5, minus, we're going to have the load. The next load is the second axle. The next load is the first axle. The first axle times the distance of the second axle will give you 12.65 open bracket 4p over 2b. All right, so this is 2b. Okay, so this gives us the value for the maximum moment of a simply supported bridge using the orthotropic plate method. Okay, remember we've also done a video on pre-stressed concrete. If we are to obtain the moment at various points along the deck, we've done a video on that, so please, you can as well check that video. Of course, if you are doing reinforced concrete bridge design, you don't need to go through that. All you just need to do is to obtain the maximum moment on the deck. Once you've obtained the maximum moment of the deck due to HB load, you can multiply that moment by the weight of your beam, the center to center spacing of your beam, to obtain the gross moment on your beam. All right, so I haven't gotten this as a maximum moment of our deck, which is in kilonewton per meter weight of deck. We can multiply this moment by the center to center spacing of our beam to obtain the moment on our beam. All right, so this brings us to the end of this brief lecture. I'll see you in our next class. Do well to subscribe and have a wonderful day. See you.